Hello everybody. So in this video, we're going to be going over how to find the determinant of matrices. Specifically, how to solve for the determinant of a 2 by 2 matrix, as well as how to solve for the determinant of a 3 by 3 matrix. So, we'll start with the 2 by 2 matrix because it's the most simple case. So when you're dealing with a 2 by 2 matrix like this, you'll have 4 terms, and so what we're going to do is multiply the terms in a crisscross pattern. So we're going to start by going from top left to bottom right. So we'll multiply these two terms. So we have 2x times 7, and that gives us 14x, which is the first part of the determinant. From there, we're going to go from the bottom left to the top right and do the same crisscross multiplication. So we'll end up with 4 times 3y, which will give us 12y. And the second term, where you're going from the bottom left to the top right, we subtract that from the first term, where you're going from the top left to the bottom right. So it's going to be 14x minus 12y. We can do a few other examples just to show how this works to really get it down. So in this case, we would have 3t times 2, so that gives us our 6t. Then we're going to have 6 times g, which gives us 6g. And we're going to subtract the second value we found, going from the bottom left to top right. We're going to subtract that from the first term we found, going from the top left to the bottom right. So we're going to subtract 6g from 6t, so we end up with 6t minus 6g. And just as a side note here too, say for example this question, or this matrix I guess, was changed to negative g. So say this was a negative. So this doesn't change how we approach it at all, it's just going to change our answer a little. So we'll still do this and we'll get 6t, and we'll multiply these two, but now we'll have negative 6g. So we're going to have 6t minus, bracket, negative 6g. So these negatives are going to turn into a positive, so our final answer is going to be 6t plus 6g. Sorry, the writing isn't great with the mouse. But, so you see, all adding this negative has done is just simply changed our subtraction sign to a addition sign. So we end up, instead of 6t minus 6g, we now have 6t plus 6g. So just something to watch out for. You're not always going to have the first term minus the second term, because if the second term happens to be negative, you gotta cancel out the negatives to make a positive. But that is the general formula. Just watch out for making sure that you simplify it down correctly. So we'll look at one last one here for the 2 by 2s. So we have this matrix here, and we'll have 9u times 5v, so that gives us our 45uv. Then we'll have 12v times 3u, so that's going to give us 36uv. And then we simply take the first term, going from the bottom left, or the top left to the bottom right, and we subtract the second term, going from the bottom left to the top right. So 45uv minus 36uv. And then since we have like terms here, we can simplify it down to 9uv. And that'll be our answer for the determinant. So now looking at the 3 by 3 matrix, it works more or less the same way, but it's just a little more involved. So with the 3 by 3 matrix, it's really a lot easier to visualize the process if we create what we call the extended square matrix. So we have the square matrix, which is our 3 by 3 matrix. So this is just an example matrix I drew up. The extended matrix is just going to be the square matrix, this 3 by 3 matrix, but we're just going to repeat the first two columns. So you see these two columns just get repeated. So now we have a 5 by 3 matrix, and these two are repeated. And this just makes it a lot easier to visualize the process we're going to use to find the determinant. So I also enlarged it down here so that it's a little easier to draw lines on and show you exactly what's happening. But essentially what we're doing is we're going to go across the top columns, and we're going to do the same crisscross multiplication, So the same diagonal. So we're going to start at x, and we're going to go down diagonally. So we get x times 4y times 1. And right here you can see I put that as the first term. And like in the 2 by 2, when we're going down from the top left to the bottom right, these are positive terms. So now we get 2x times y times 3z. And still, since we're still going down to the right, this is a positive term, so we're still going to be adding it. So this gets added on to the first term. Now we're going to do x times 2 times z. And so you can see I put that again as our next term, and it's positive as well. Now you see how if we try to go to this next term, we're only going to have 2, and we're going to hit the end of the matrix before we get down to the bottom row. So we're not going to keep going. We're just going to stop going down this way here. So now we're going to go back, and we're going to do it the opposite way, going from the bottom to the top. So bottom left, top right. So we start at 3z times 4y times x. And you can see that's what we have here. Except now, since we're going from the bottom to the top, we're subtracting these terms. So now we're going minus, and all these terms multiplied. Then here, same idea, z times y times x, and we're subtracting that from the determinant, so minus z times y times x. And lastly, we have 1 times 2 times 2x. And we end up with that also being subtracted. Now, if you don't have an extended matrix when you're looking at a question, for example, and you just have it in this square matrix form, you can learn to still do this without the extended matrix. This just makes it easier to visualize when you're first learning. But essentially, say you're doing it just with this one, we start from the top left, and it's the same process. We go from the top left all the way down, then we go to the next term in the top row, and we hit 2x, y, but now we hit the end of the matrix. So what we do is we wrap around to the other end and hit the 3z. And you can see that's exactly what happens here, right? 2x times y times 3z. Then when we get to the x, we go down, we immediately hit the end, so we wrap around to the 2 and the z. And you can see that's what's happening here, x times 2 times z. And it works the same way going the other direction. When you start going up to take your negative terms, it's just going to be 3z times y times x. That one's easy. Then z times y, go across. You're going to hit the x. And then 1 times 2x. So it's just like you wrap around and go up to the next one. So the 1, we wrap around, go up to the 2. Or when we're doing it with the z times the y, wrap around, go up to the x. So now we have all these terms, and then from here we would just multiply the terms out. If you have any like terms, you can subtract them. I didn't do it here. This would be the determinant. Like I said, you can feel free to simplify it, but this is the determinant of this 3 by 3 matrix. Just to put a remark here too, this technique only works with 3 by 3 matrix. So if you have a 4 by 4 matrix, you can't use this technique of crisscrossing and going across the matrix. So now we'll look at a trick for doing these 3 by 3 matrix a lot easier than doing it that way. So the trick is what we call decomposing the matrix into minors to find the determinant. So you'll see if we do how we were doing it up there, a times e times I, we'll get this as our first term, and so on. Just exactly as I showed you previously, we'll get all our terms here, and we end up, whoops, that's not where I want to put that. Just like this. And we'll end up with all these terms, so on and so forth. But if you look at these terms, we can factor out a common value from a lot of them. So you can see that we have an a in this term, and we also have an a in this term. So we can express this as a times ei minus hf, right? If you multiply it out, the a goes into this term, a goes into this term, you just get what you started with. And then it's going to be minus b, and b can be factored out from both these two terms, b times id minus fg. And then plus c and the same idea, C is being multiplied by what it's been factored out of these two, so DH minus GE. And so when you're figuring out how to know whether the sorry, I'm just thinking of the word I'm trying to look for here. I guess I should put it this way. When you're trying to figure out whether the term that's being multiplied here should be positive, or here, like in B, I have it negative, you just fall back to this pattern. So A is the term that's being multiplied to the two terms inside the bracket. And since A is on a positive term in this order of the matrices, like you call this, I guess, the positive negative order of the matrices, then A is going to be positive. Then we go to B. B is in this position right here, middle of the top row. So B is going to be negative, so we're going to be subtracting B. And then lastly, C is positive, so C is going to be added with the terms it's being multiplied out to. And so, and then this last column here, I just shifted a few of the letters around just to make it a little more obvious as to how this is going to work. And you'll see it in the next step here. So what you'll notice here is now we have A being multiplied by EI minus HF. Well, this EI minus HF is simply just one of the 2 by 2 determinants that we dealt with earlier. So we can make a matrix, a 2 by 2 matrix, that represents EI minus HF as its determinant. So we make this matrix, as you can see, its determinant is exactly what's inside the brackets. Same thing here. The determinant of this is exactly what's inside the brackets here, and same here. The determinant is exactly what's inside the brackets of this matrix. So now we can re-express this 3 by 3 matrix as the addition of 3 2 by 2 matrices being multiplied by different terms. So moving here, I'll just show you. We have the extended matrix, and so you can see that, like I said, this is just how you're getting the terms that are all up here and going down, just like this. So there's a lot of explanation on how we get to this, but there's actually a much easier way to do this when you come across the question. This is just kind of the reasoning and logic behind why we can do this trick. So, but most likely you're not going to write all this out when you come across a 3 by 3 matrix that you need to solve the determinant for. There's a much easier method to figure it out a lot quicker. So this is kind of the trick on how to do it. So we're going to pick a row. I always just pick the top row, but if there's, for some reason, it makes more sense with the matrix to use the bottom row or the middle row. You can even do columns as well, technically, but I always just use the top row. So we'll pick the first term in the top row. We're going to fully get rid of the column that that term is in and the row that that term is in. So if we cross all this out, you'll notice we're left with a 2 by 2 matrix. And it's the same 2 by 2 matrix that we simplified all this down into. So when we're figuring out the determinant for this matrix, A was the letter we selected from the column, so this is all going to be multiplied by A, and it's going to be times the determinant of this matrix. So you'll have A times, and then you just solve this matrix here. And then for the next term, you just simply move over to the next column, or the next term in the row. So we'll cross out the B, we'll cross out the ABC, and then we get this matrix here. So ignore these two and just pretend this is a 2 by 2 matrix and these two are next to each other. So D times I, G times F, and you'll see this is the exact same matrix we had here. Then from there, we'll just move on to the last part. So then we'll cross this out, and C is the value we're using. It's the third term in the top row, and we'll cross this part out, and we end up with D by H, G by E, and this is exactly the matrix we came up with here. If you're wondering why this some terms are positive and some are negative like this, it makes a little more sense to look at um, this extended matrices here. So if we look at how we're multiplying when we do the extended matrices, when you get to B, it goes B and then F and G. And if we're going up here too, same thing, I, D, then B. So since we're going all the way down, we're going and hitting F and G, you can see that F and G actually are in opposite spots than where they're supposed to be when you do this matrix. And you'll also notice it's the same thing, I and D are flipped. So everything's actually flipped in this matrix when you do the extended matrix. So we're going to end up with the negative. So that's why we take the negative of B to counteract the fact that we're crossing over to the other side of the matrix. So now we can try an example with this method. So say we want to find the determinant of this 3 by 3 matrix, and we're going to do it by decomposing the matrix into minors, like we just learned. So this is our solution. So we're going to start with this top row, and we're going to start with 2. So 2 is our number. So as you can see, out here I have 2, and it's going to be times the matrix that's left when we cross this out. So we're left with this matrix here. Then we'll move on to the next term in the top row. So we'll cross out the column it's in, cross out the row it's in, and you get negative 9 times 5 and 10 times 1, same matrix that we have here, and negative 3 was the number, or sorry, just 3 was the number we used, and the reason it's being subtracted is because of our little pattern here. This is the position 3 was in, so it's going to be negative. Then moving on, we'll get to negative 4. So cross out the row it's in, cross out the column it's in. This is going to be our matrix, as you can see here. And then we're adding it, but it's negative 4, so ultimately it'll be subtracted. So we can go ahead and erase that. So then from here, we solve these 2 by 2 matrix just like we learned earlier. So we have the 2 from the outside, right there. And then it's going to be 2 times 5, which is 10, minus 3 times 1, which is 3. Same thing here, the 3 comes down, and then we're going to have negative 9 times 5, which is negative 45, minus 10 times 1. And then lastly, we're going to add, and the negative 4 comes down, and then it's just the determinant here. Negative 9 times 3 is negative 27, 10 times 2, minus 20. So after we multiply these terms, we'll end up with, or I guess I just did the subtraction first, so we end up with 2 times 7 minus 3 times negative 55 plus negative 4 times negative 47. And then from here it's just basic arithmetic. This equals 14, this is negative 165, this is 188, and then the two negatives cancel each other out, so we just have positives, all addition. And our final answer here is 367. So instead of writing out a really long-winded way like this, where you have, AEI plus BFG plus CDH minus this, minus that, minus so on, you can simply write it this way. And when you get good at doing this in your head, you don't even have to draw out this matrix. You can just quickly calculate the value of the determinant of the 2 by 2 matrix and multiply it by 2 and just put that down as the value. So once you get used to this method, you probably will skip pretty much at least all of this step. If not even this step, you could probably skip all of this and you'll just be doing these 3 steps really in your head, because all of this you can do in your head. So that's the trick to doing 3 by 3 matrix, which we call decomposing the matrix into minors. I hope this video helped you with figuring out how to find the determinant of matrices, and I hope to make some more videos soon. I'll see you guys later.